A diagonal of a polyhedron is a line segment connecting two non-adjacent vertices. How many diagonals does a pentagonal prism have? To answer this question, what I did is I drew another pentagonal prism which shows all the vertices uh, much clearly, and also I named the vertices. Now to solve this you can use a formula, but I didn't. I just thought it would be nice to draw the diagonals or find out, name the diagonals and then count them, because this is really a question about counting. So then if you start from one of the points, so I started from A, if you start from A, the diagonals from A would be AH. So you would have like AH, then you'd have AC, then you'd have AF and AE, and then you'd have AD and AJ. So what you see is the points G and B and I, they do not, there are no you can't have any diagonals from A to these points because they are the adjacent points. So you just have to remove the adjacent points, like not count the adjacent points. So anyway, so those are the diagonals from A. And then if we do the same for each of the other vertices, what we get is, so diagonals from A would be 6, like the 6 points, 1 2 3 4 5 6, 6 diagonals, I mean. And then if we do the next one, diagonals from B, so if we do the same again, so then you'd have a BG, you'd have BH, and you'd have a BE and BD, and of course BF and BI. So again we have 6 diagonals from B. The next point, the diagonals from C. Here again we can have 6 diagonals, but here we are counting the diagonals and we cannot repeat. So we see that CA we have already counted before in diagonals from A, so we have to ignore the CA. So we've got 5 diagonals. Once again from H, when you do the diagonals, similarly you will get HA, HB, HI, HF, HD and HJ. And you'll notice that HA has already been, or is already appearing before. We've already counted HA before. HB also we've already counted before. So the only 4 diagonals we haven't counted so far are these. And so we have just I have put in 4 there. Otherwise it would be a repeat counting. So again, diagonals from G. Again I name all the diagonals, and the ones that have appeared before are underlined in orange. So GB has appeared before, has been already included in B, and GC has been included in C. So we can't count it. So we have 4 diagonals that you can count from G. And again from D, when you do all the diagonals, how many can you count? You can only count DI and DF, because again DB appears with B. You have got BD. BD and DB are the same. DH would appear before, has been counted before, has HD, and DG has been also counted before as GD, and DA has been counted before as AD. So we ignore, we don't count these anymore, and we have 2 original diagonals. And from E, again, the same thing applies. We have to um, we have to delete EB because EB has been counted before. Um, you see here with B and E, that's EB. EB has been counted before, so EB cancels out. EC has been counted before. If you go to C as CE, EA has been counted before as AE, and EG has been counted before as GE. So that is why we don't count this again. And then diagonals from F. Here you see 5 of the diagonals have already been counted before. So we do not include them in the count once again. So only Fj hasn't been included, so we write Fj. And this way, if you then go to the point I, from I the diagonals that you will be drawing, you can again draw 6 diagonals, but you have counted all of these before, so we cannot include them in our counting. So there are 0 diagonals that we count from I. Okay, that doesn't really mean there are 0 diagonals that you can draw. It really means 0 diagonals can be counted. And also, when we do diagonals from J, it's the same thing. All of these diagonals have been counted before, so we do not include them in our count. So what is the total number of diagonals? The total number would be 6 plus 6 plus 5 plus 4 plus 4 plus 2 plus 2 plus 1, and that gives us 30, which is the answer.